Then again, there's some difference here. Science itself, NA or Express O levels, right, will do the same learning objectives. So you have like part D where you have redox reaction. That one is only for the pure chem students. Then the CFCs, etc., carbon cycle, then your greenhouse effect. I think greenhouse effect, is also only for the O-level chem students. Number one thing to know, even back in primary school, they would have told you that in air, there is nitrogen and oxygen. Then there are other gases. Other gases can be noble gases and carbon dioxide.
Carbon dioxide.
And there's water vapor too. So air is a mixture of gases. So nitrogen, these numbers are very important. So if nitrogen, oxygen, like these percentages, then the rest, right, other gases. Other gases here, water vapor is included here. Then you have carbon dioxide here. So this two number is the important one. And then it serves as the basis for most of the chem question in your paper. So here comes the question. They say you have this setup, and this setup is used to find the percentage by volume of oxygen in air. So they have 100 cm cube of dry air in strange A. Then whoever doing the experiment will force the air through this middle setup and then go over to here. Then after that, right, they will do this a few times, and eventually they will stop this when there is no further decrease in volume. So the final figure down here is 79 cm cube. Yeah, 71. So what happened is the logic is because the copper here reacts with oxygen. So whichever that is left behind, right, this will be the nitrogen. So 21 cm cube of oxygen is used up. Then by math, right, then you will be percentage will be equals to 21 over 100 cm cube. Then this is the example that they love to use when they want to derive the amount of oxygen inside a particular air sample. So this, I think, is a little extra. So what these slides are about is how you separate air into its different component gases. Then they say liquefy the air. How do we make air become a liquid? Then I have a bunch of text down here. Then I say air is filtered to remove dust and then cool down in stages until it reaches negative 200. Is it easy to reduce temperature to negative 200 degrees? What do you think? No. Yeah. So what's done, right, is they would increase the pressure on the gas. Then when they increase pressure on the gas, right, the gas will get compressed and then it will cool down and then it will start to liquefy, which means it's very high pressure too. But we don't need to know the exact procedure of how to liquefy the air, just for interest sake only at this point of time. So what you do is you liquefy the air. Before you liquefy, you need to filter, because if you don't filter, all this dust will contaminate the air. Then you cool down. They say cool down in stages, because after in stages, right, carbon dioxide will come out, it will freeze. Then you can filter the carbon dioxide out from the mixture. When temperature hits negative 79 degree, carbon dioxide will be solid. Then you can filter. So getting rid of carbon dioxide is also by filtration. Then when it hits negative 200 degrees, right, oxygen and nitrogen will be liquid already. So the final mixture that you have will be in liquid state, and it's only oxygen and nitrogen. Then when you have that, right, the liquid air, which is only nitrogen and oxygen, right, then you do fractional distillation. Do you remember what fractional distillation is? Fractional distillation is one of the first few topics, right?
It involves two liquids with different boiling points.
Then they will just heat up. Then one will be removed earlier than the other, right? Yeah. So in this case, what they do is they put liquid air inside the setup, and then you slowly heat it up again. So the liquid oxygen and liquid nitrogen, right, they have different boiling points. So you can separate them via their difference in the boiling point. So you see the very significant difference down here. Oxygen will be at below of the setup, nitrogen will be on top. Then earlier on we say liquid oxygen will change state at negative 183, and then the other one at negative 196. So you can get rid of one first. So there is another argon inside, you can also get rid of it in this setup using fractional distillation. So for you, right? You don't need to know the steps. You just need to know if you want to get oxygen from some chemical procedure, it will be fractional distillation of air. You just need to know the answer, one answer. Okay, we have more questions. Question 2A. So we have a setup, and this setup is used to measure the percentage composition of oxygen in the atmosphere. Then the test tube contains 100 cm3 of air. After the reaction, calculate the volume of air remaining in the test tube. Very simple, right? It's very obvious. Yeah, it's very obvious because this you only have that two numbers, and it's that two numbers are always recurring and repeating. Then after that, it say explain your answer in A. So use whatever we discussed earlier, and we also have that short discussion on answering technique to answer this question. Okay, so we explain your answer in A. In A, we want to explain, okay, why after the reaction, right, the volume is 79. So does your answer explain that? Then what is lacking? You want to add some more or cancel away something and rephrase or whatever? It's 100 minus 21 equals to 79 units. You must paste a card on your screen, units. On your test paper, you also need to write units, one big word units there. Okay, much better now. The diagram below shows a sample of X cubic centimeter of air trapped in the syringe. Then the air is slowly passed over heated iron. Now not copper, now it's iron. Until there is no further decrease in volume. Name the compound form. Okay, write a chemical equation for the formation of this compound. Fe plus oxygen. Yep. If the volume of gas remaining in the syringe is 47.4 after cooling, what is the value of X? So you have to figure out 47.4 is which gas, then what percentages, then use whichever math to do it. So this is an experiment. You passed in air to the iron oxide and not to the iron, and iron oxide is formed. So at the end of the whole experiment, all the oxygen is used up, right? Then nitrogen in air will be left behind. So it will be unused. And nitrogen gas is the one that is remaining in the setup, which means, right, this 47.4 is nitrogen gas, right? And you would know that 79% is nitrogen, which means 79% is 47.4 cubic centimeter. Do you still need help? You need? Okay, let's see the answer.